Hello everyone, welcome back to my YouTube channel. This is Mr. Hussein Mosapi. In this video, we'll be looking at how to calculate the work done by an additional force on a vertical spring. So before we begin, don't forget to like and subscribe to this channel. Alright, let's get to it. The only way you can understand this is through an example. So I'm going to explain one example that will help you understand how to go about it. Suppose we have this example: a spring of an extended length of 10.5 centimeters is suspended vertically from a fixed point as shown below. A mass of weight 2.7 is hung from the spring as shown, causing the length of the spring to change to 15.2 centimeters. An additional force F is added and extends the spring to a length of 20.0 centimeters. An additional force is added. As you can see below, now calculate the work done. Sorry, it's supposed to be work done by the addition of force, and take the spring constant K to be equal to 60 newtons per meter. Alright, so now how are we going to go about solving this? Very simple and straightforward. So this is solutions. So to find the work done by the addition of force, the work done by the addition of force F should be the difference in the potential energies that were created by the spring and by the mass that was attached to the spring. So we say work done is equal to the change in elastic potential energy of the spring minus the change in gravitational potential energy of the mass attached to the spring. Let me just do this. So this implies that work done is simply equal to half K change in x squared minus mg change in height. To be precise, the height is not really the height, it's the final length. So this will be half K change in x squared minus mg change in length final. So this is the formula that we use to calculate the work done by the additional force. So basically what we need is simply the change in gravitational potential energy first. So let's find the change in gravitational potential energy. Change in gravitational potential energy of the mass, which is going to be equivalent to mg change in length final. So this implies that the change in gravitational potential energy is equal to mg, which is the weight, multiplied by length final 2 minus length final 1. We did this in our previous videos. So change in gravitational potential energy of the mass will be equal to weight times length final 2 minus length final 1. So if we substitute, the change in gravitational potential energy of the mass hanging on a spring will be 2.7 times length final is 20 divided by 100 minus length initial, which will be 15.2 divided by 100, like that. If you do your math correctly and compute, you'd find that the change in gravitational potential energy of the mass that is hung on the spring will be equivalent to 2.7 times 0.048, and the change in gravitational potential energy will be equivalent to 0.1296 joules. Upon finding the change in gravitational potential energy, we need now to find the next data, which is the elastic potential energy. So the change in elastic potential energy of the spring is half K change in x squared, which is the change in elastic potential energy being equivalent to half K, then this will be extension 2 squared minus extension 1 squared. If you compute this rightly, you have the change in elastic potential energy to be equivalent to half times 60, and this will be if you collect your the data and look for extension 1 will just be length final minus length initial, which will give you something like 15.2 minus 10.5, which gives you 4.7 divided by 100. So extension 1 will simply just be 0.047 meters. For extension 2, simply do the same thing, length final minus length initial, which gives you a change of 20 to 10.5, which gives you 9.5, then divided by 100, change it in meters, then extension 2 will be equivalent to 0.095 meters. These are the values we'll use. So we're going to put 0.095 squared minus 0.047 squared. If we compute this on our calculator, the change in elastic potential energy will simply be 0.20448 joules. Now remember, we said that the work done by the force that has been added to the spring is equal to the change in elastic potential energy of the spring minus the change in gravitational potential energy of the mass that has been hung on the spring. So work done will be equal to the value of the change in elastic potential energy, which is 0.20448, minus that of the gravitational potential energy, which is 0.1296. So the work done by the additional force F will now be 0.07488 joules. So if we round this off, the work done by the additional force is simply just 0.07 joules. Alright, I hope this is clear. For more questions, you can contact me on WhatsApp on the number that is indicated in the top left corner. Remember, to understand this topic clearly, make sure you watch all the videos in the playlist. Watch all the videos and understand up to now. Alright, my name is Mr. Hussein Mosapi, and don't forget to like and subscribe to this channel. Remember to strategize before you become a statistic, and let's try and push for that A+.